Hello guys, this is my second video on nodal analysis. In this video, I'll be looking at a circuit and analyzing it using nodal analysis. But the circuit we're looking at is a circuit that has something known as a SuperNode. Now let's fully understand what a SuperNode means. So if you look at this circuit, we have 1, 2, 3, 4 nodes. Nodes are junctions, anywhere two wires meet. We have one wire coming from this source, one coming, and then one. This is called a node because the current can go either way, right? Either of the three ways. And that makes it a node. This is not a node or a junction because it's just wiring. You just bend your wire or whatever. But those are not nodes. So this is not a node, these are no nodes, not nodes. We have 1 node, 2 node, 3 node, and the 4th node here. Now this 4th node is where we have our ground. Wherever you ground your circuit, your voltage is 0. Such a node is referred to as your reference node. Every other node that isn't grounded is referred to as non-reference node. So in this circuit, we have 1, 2, 3. 3 non-reference nodes with voltages V1, V2, V3 assigned. Now, what is a supernode? When you have 2 nodes, ensure they are non-reference, that is, they are not grounded, and then you have a voltage source between them. So what it means is that we have this node N2, N3, non-reference because they are not grounded, and we have a voltage source in between them. That makes it a supernode. What it means is that when you do KCL, Kirchhoff's current law, the same way you treat a single node, a regular node, is the way you will treat your supernode. So let's try to analyze this circuit. So we will have KCL. Now, we don't have much to analyze on this side, right? So I'm just going to assign current on the branches that has a resistor. So we have, and I can pick any direction, right? So I'm just going to pick this for this, and since it's R2, I'll call it I2. This is R1, I'll call the current going through it I1. And I can pick it the other way around. It doesn't matter. I can point it left instead of right. Likewise this. Now for this one between V2 and ground, I like to point them downward. Why? Because I have my ground here. I am assuming that the potential here is higher than the potential here. Well, this is 0 unless this is negative. This is going to push the current, make the current go the opposite, outward, right? Not towards it. Because current moves from higher potential to lower. So, and you can decide to, choose any direction. It doesn't really matter. But I'll maintain that direction, so I'll call this I3. And then same thing here, I4. Now I don't care about this branch because I don't have a resistor there. But before we even do the KCL, what can we deduce from this? From this node, or from this branch? This branch is saying the voltage difference between this non-reference node 1 and this node 4 is what? The source there. So at least we can get some, make some sense out of this branch, right? Even though we don't care about the KCL, we don't care to do current, consider all the sum of currents going in there. So for node 1, we can get an equation that says the V1 minus V0 is equal to what? Vs1, the voltage. It is V1 minus V0 because it is plus minus. So this potential up here is higher than this potential down here. If it is the reverse, I'll do V0 minus V1. Is that clear? I'm just looking at my sign. This potential is higher than this potential, so this minus this will give me this. Now, if it were the reverse, plus here, minus here, I'll do the V0 minus V1. But what? V0 is 0. Therefore, what? V1 is equal to Vs1. I'll call this equation 1. Now we would look at our SuperNode. Now, remember, SuperNodes are what? Treated as regular nodes. What this means is that if we apply KCL, and I'll call it on what? SuperNode that we have, we treat all this as one big black box, right? I can shade it and just look at it. Look at this whole area as one node. Current coming in, going is equal to current going out. Do you see it? Yeah. Or we can use the sign convention that says current going in is positive, right? So summation of all the currents going into the SuperNode is 0, with the convention that inward current flowing in are positive and current flowing out are negative. You can choose whatever convention you want. So that means we have I1 going in, I2 going into this SuperNode, I3 going out, right? And I4 going out is equal to 0, right? Now, what makes it nodal analysis? When you express all this current in terms of the voltage drops around them, across them, I mean. So, I1, the current is flowing this way. So the voltage drop will be V1 minus V2. If it were flowing this way, if we chose this direction, then it would be V2 minus V1. So I1 is what? V1 minus V2 over R1. Current is potential voltage dropped across a resistor divided by the resistance of the resistor. Similarly, I2 is what? V1 minus what? Because you look at the voltages at each end of the resistor, right? So V1 minus V3 divided by what? R2. Now we're here. I3 is flowing downward, so it's going to be V2 minus V0, right? Divided by R3. And then the last one is I4. So this one can further be written as this. And then the last one will be I4, which is V3 minus all this all this area is 1. So all this is the ground reference node. So this would be the same V3, divided by R4. Because it's V3 minus V0, V0. So I'm just gonna, let's call this 2, and I will call all these 3. Now we're gonna substitute all these values into 2. Now you will see that everything will reduce to an equation in terms of nodal voltages. And that's the essence. So I'm just going to draw a line here. So we're going to substitute equation 3 into what? 2, right? So I1, in place of I1, we have V1 minus V2 divided by R1. I2 is V1 minus V3 over R2, right? Minus I3, which is minus V2 over R3. And then the last one will be minus V3 over R4 equal to 0. Now, if you look at this, it is, let's simplify first, and then, so I'm just going to collect all the like terms, right? So V1, I'll have V1 into 1 over R1 plus 1 over R2, right? Plus V2, V2 is minus, so minus 1 over R1 minus 1 over R3, right? And then the last one is V3, which is combination of these two, right? Have I missed anything? No. 1 over R2 is minus 1 over R. How many unknowns? 1, 2, okay. 1, 2, 3. All the voltages are unknown. Well, we have one already. But when you have 3 unknowns, you need 3 equations. So we have one more equation. And that's what makes a circuit with a SuperNode kind of easy, because we have a SuperNode equation. And what's the SuperNode equation? This voltage source, positive, negative, is the difference between these nodal voltages. That's the extra equation. This is positive, this is negative, so you have V. We have V2 minus V1 is equal to the source between those sources, between those nodes, I mean. And now you have equation, I'll call this equation 4, and you have equation 5. Now, solving to find all the nodal voltages, you just need to use 1, 4, and 5, right? And you have 3 unknowns, you have 3 unknowns, you have 3 equations. You can use those equations to find all the voltages and then come back here and find the currents if you're interested in finding the currents, right? And that's it. So to find V1, V2, and V3, solve 1, 4, and 5 simultaneously. Right? So we're just going to plug in values. solve this circuit, right? So I'm going to wipe this off and analyze it from beginning again, but you already have this as record. So if we have values plugged in, okay, just going to wipe this, and I don't like wiping it off, but have to. So that's how you analyze a circuit using nodal analysis, even when you have a voltage source. So I'm just going to check for an equation. Well, the same, I'm going to use the same circuit, but with values this time around. So let's assume this is 4, 2. Okay, actually, I drew it wrongly. Well, it's correct now, but this is 2, 4. And then I have 10, 5, 8, and 6.
This is all?
So VSI is 10. This is 4, this is 2. I believe this is 8 ohms. This is 5 volts, ohms. And the last one is 6 ohms. So now, we already have the expressions, right? We have what? First of all, from the this is not a SuperNode. So it is a voltage source between a non-reference and a reference. Makes it easy. From node 1, we have what? V1 minus what? V0 is what? 10. That was the first equation we got, remember? VS1. And VS1 is 10 in this case, right? So, as simple as that, this is 0 because it's grounded, it's our reference. V1 is 10 volts. Right? Now we'll go to KCL for our SuperNode. KCL for the SuperNode, right? I'm just doing it again without using the equations, just so we get used to it and see how easy it is, right? KCL. I1 is flowing in, so we're doing summation of current flowing into the node with inward flowing current as positive, outward as negative. So flowing in, I1, well, let me write it here so I'll make best use of my space. Flowing in, I2, flowing out, I3, I4. Now, what is the Ohm's law for all these guys? So I'll just say Ohm's law, right? Says the current is the potential drop across divided by the resistance of the resistor. So the current I1 will be voltage drop, which is this minus this because it's flowing this way. So we have I1 is V1 minus V2 over divided by 2, right? Because I have the resistor, or R2, which is V1 minus V2 over 2, because that's the value, right? I2 is V2 minus V0 over, sorry, I2 is V1.
V1 minus V3.
Oh, sorry, that's I2. V1 minus V3 divided by R2, which is V1 minus V3 divided by what? 4, right? Right?
Right.
I3, I was skipping, is what? V2 minus V0 divided by R3, and this will be V2 over divided by 8, right?
Yes.
And then the last one is I4 is V3 minus V0 divided by R4, which will give me V3 over divided by 6, right?
Yes.
All this equation is what I call, so this one is 2 is what I call 3.
Can we use the value for V?
Oh yeah, well, I'll leave this last, but I'll update all this equation in 2. So I'm substituting all of 3 into what? 2. So instead of all these i's, I'm gonna have these values. So we have V1 subtracted V1 minus V2 over 2 plus V1 minus V3 divided by 4 minus V2 divided by 8 minus V3 divided by 6, right? Right?
Mm-hmm.
And then we'll just collect like terms. V1 bracket 1 over 2 plus 1 divided by 4, right? Plus V2 minus 1 divided by 2, that's, I got it from here, minus 1 divided by 8, right?
Mm-hmm.
And then the last one is plus V3 into minus 1 divided by 4 here, minus 1 divided by 6. I can just simplify this. Now this I can write as 1 over 2 is the same thing as 2 over 4. 2 divided by 4, right? 1 over 2. So this and this will give me 3 over 4 V1, right?
Mm-hmm.
I don't know if it's, this is 1 over 2 is the same thing. I just want the denominators to be the same for whatever I'm adding. So this is the highest denominator, right? I want this to be 8. 1 over 2 is the same thing as what? 4 divided by 8. So now I can just directly add the 12. So this will be minus 5 divided by 8 because they are both negative. They'll add but maintain negative.
V2.
And this one, the denominator is 4 and 6. There's no one single number I can multiply. Well, I can multiply by 1.5, and this 4 multiplied by 1.5 is 6, and then I'll have 1.5 at the top, but I don't want to do that. So I'll multiply this one by 3. So I'll have 12 here and 3 here, which is still my 1 divided by 4, but I'll multiply this by 2. So this will be 2 here and then 12, which is still my 1 over 6, right? Right?
Right.
So this will give me minus 5 divided by 12, V3, equal to 0, equation 4. Now the last piece of information is the Nodal SuperNode equation. SuperNode equation. And this says that the voltage difference between these two nodes is equal to the voltage source. It means what? V2, since it's positive, negative, 2 is at a higher potential than 3. And that's why we do V2 minus V3 is equal to that voltage source here, which is 5. And we call this what? 5. So we're going to solve equation 1, 3, 4, and 5. Solve 1, 4, and 5 simultaneously. We can decide to just plug in this value or use echelon row reduction, right?
Mm-hmm.
Reduce, we make it into a matrix and solve. Well, you don't really need to do that in this, you know. Do you want me to do that here or
Yeah, I do.
using that method, right?
Yes.
Okay, we're going to use the reduced row echelon form. Now, my equation 1, I will rewrite it.
Mhm.
My equation 1 is what? I wanted to show all the variables, V1, V2, V3. My equation 1 is just V1 is equal to what? 10. So I can say V1 plus 0 V2 plus 0 V3 is equal to 10, right?
Mhm.
And my equation 4 is 3 over 4 V1 minus 5 divided by 8 V2 minus 5 divided by 12 V3 is equal to 0. And then my 5 is 0 V1 because we don't have V1 there,
Mhm.
plus V2 minus V3 equal to 5. We're going to solve this simultaneously. So I will rewrite it. This will give us what? The matrix 3 divided by 4 minus 5 divided by 8 minus 5 divided by 12. Here we have,
You will not write the 1, 0, 0.
well, I could write any one first, but yeah, you're right. Let me write it in the order I wrote it there. I skipped 1, 0, 0, yes. 3 divided by 4 minus 5 divided by 8 minus 5 divided by 12. The next one is 0, 1 minus 1. All the V's here, V1, V2, V3. And then the result, which is 10, 0, 5, right? I don't want to delete this, but I will. I'll write it back on the other side. Now, to find V1, V2, V1, V2, V3, you can solve the reduced row, find the reduced row echelon form for the augmented matrix, which is 1, 0, 0, augmented with the values, the result, the answer, the right-hand side of the equations, right? That's what it means. It's augmented by adding that extra column. Do you want to use your calculator?
I can use it.
We already found V1 to be 10. We're just using the long method just to show the whole process. But we already found that V1 is 10. And I'll just try and do it mentally. Let's see.
I will use my calculator and you do it mentally.
Okay. So let's see. V2 minus. Are you done? It's harder than I thought. You done?
Yes.
What's the result?
Fraction.
So, tell me the result.
The first one 10.
Okay,
The
for sure.
second.
We know that.
115 over 17.
Are you sure?
Yeah, this is what I got.
Okay, and what's V3?
30 divided by over 17.
Doesn't sound correct. Check it again. Because what I got is different. Let's see. We have 10, 0, 5. Okay, you have a mistake. I'll show you. Wrong. Look at your second row, second column. You see the mistake, right? Yeah. So this should be 4.2 volt. So whichever way you choose to solve it is fine. We already have that V1 is 10. So you can just update the equation by substituting V1 equal to 10 here. Now you have an equation that is in terms of V2 and V3. Two equations that is in terms of V2 and V3. And that makes it easy. Is that correct? Okay, yeah. Press that to see the answer in fraction. 21 over 5 is correct. 46 over 5. So yeah, 4.2. Check. 4.2 is 21 divided by 5.
Yeah, you're right.
Okay, so yeah, so 21 divided by 5, 46 divided by 5, right?
Volt.
They're all voltages. Okay, good. Now we can find our currents, right? Our current, remember, I1 is V1
Minus V2.
I1 is V1 minus V2 divided by what? 2, which will be 10 minus, calculated, 46 divided by 5 is 9.2, right?
Yes.
So I'm just going to write 9.2 here, volt, and this is 4.2. 4.2 volts. So 9.2 divided by 2, this gives 0.4 amperes. I2 is V1 minus V3 divided by 4. 10 minus 4.2 divided by 4.
1.45.
1.45?
Yes.
45. Okay. 5.8. Okay. And I3 is what? I3
Minus V2.
V2, no, not minus.
Yeah,
V2, you said minus V2, divided by 8, right? V2 is 9.2 divided by 8, which is what?
1.15.
Ampere. And then the last one, I4 is what? V3
divided by 6.
Which is what?
0.7.
4.2 divided by 6, which is 0.7. And that's the end of the question. You see, even with a SuperNode, it's still easy to analyze. As a matter of fact, it makes it a little bit easier because you drop one node out and just have the difference in voltage equal to the voltage source. Also, this kind of helps because directly V1 is equal to this because V1 minus 0 is this. So when you have voltage source, you can still use nodal analysis to to find all the currents and the voltage drops, and it kind of makes it easier. Just know that your SuperNode is treated as one, and you get another equation by finding the voltage difference between the node, equating it to the voltage source in between. And you have a question?
You will do the mesh analysis with SuperNode?
Yeah, so I will have subsequent videos that will treat mesh analysis, that several other topics that will follow. We'll also do circuits that has resistors and capacitors, so we do the RC, typical RC circuits. So, stay tuned, please subscribe, and I hope this is useful for you. Thanks for watching.